Good morning, ladies and gentlemen. It's Mr. Pearson coming to you guys with another physical science update. It is Wednesday, January 6th. We are moving on in Unit 2, Investigation 1. All right, I mentioned on Monday, we're sort of dwindling down to the end of the semester here. All right, I actually just got off of a meeting this morning. Some information about final exams. I'm going to go live with you guys. I know it's been a while, really since we started the hybrid program. But now that we are, for sure not going to be coming back in any sort of hybrid program until the switch of the semester, I'm going to start mixing back in some live sessions. And really what I want to do tomorrow is just go over when those live sessions are going to be and what our calendar is going to look like in the next coming weeks. So live session tomorrow. I'll send out plenty of reminders to make sure you guys all get where you need to be. Anyway, for what I'm publishing today and what we're working on the next 2 days, all right, we are going to wrap up with Unit 2, Investigation 1. And by that I mean we once we're done with Investigation 1, we're not going to get to any more new material. Okay? So what I put up today, we're in Unit 2, Investigation 1. I actually published Act 1.2 and Act 1.3. Okay? 2 questions. What happens to energy when objects collide? So I'll start there. There's some labs that we would have done in person that it references and asks you about. However, if you go and you're on the Interactions website, and this is where it's talking about the labs, for time's sake and because we're without materials, you're more than welcome to just skip over these portions where it's asking you about the lab and any data that might go along with it, because there are some simulations to support it, okay? Could sort of serve as a replacement, and these simulations are going to help you with the checks for understanding and things like that. So just a quick, I don't know if you're going to be able to see all that. Just to give you a quick overview of what we've got here. Okay, we've got a couple sliders. We've got 2 particles. All right, and I can change, this is the speed. And you'll notice that this arrow is getting larger and smaller as I make the speed greater or less. Okay, so I can make them go faster or slower. I can also change their mass, right? I can change their mass all the way up to 5 kilograms, all the way down to 1, okay? And then this is sort of offsetting them a little bit, where you can have them either colliding head on or a little bit offset one way or the other. Okay, and as you play, you'll notice there's a couple of graphs here. There's a bar graph showing us the kinetic energy. This is a type of energy associated with motion. Remember, this is something we should have seen in middle school. Kinetic energy of the left object being the orange and the right object being the, it's like a teal color. All right, and those colors translate over to these graphs. Okay, I know it's kind of, I'm just going to pause it here. I could even reset it to wipe all that stuff out. But if I play it and pause it real quick, I can see these teal portions are going to match up. That's corresponding with the teal ball. The orange portions are going to match up. That's corresponding with the orange ball. Now, the one thing that's missing in this image is this gray figure. representing the total, right? What is it all added up? So that's a little bit on, there we go, on activity 1.2. All right, remember there is a check for understanding here. Go back. Like I said, I opened up activity 1.3. Because we're skipping over these labs, we should be able to get through both of these. Again, sort of just a time crunch. Similar deal here. The only thing different is there's a warm up, sort of reflecting on what we just saw in activity 1.2. But just to jump over here, we are looking at, instead of now particles like marbles or like a car colliding, we are looking at water. I'm not sure. This is something that you might try to do at home. I'm not sure if you've got food coloring or not. If you've got some sort of like drink mix, or like maybe like cranberry juice or something like that, can be an effective substitute. Take a cold glass of water and take a hot glass of water, or a hot mug of water or something like that. Don't burn yourself. But just, it's a cool little demonstration to see how quickly the color spreads out in a body of water, depending on what the temperature is. Okay. Again, if you don't have those materials, it's not going to be the end of the world. There is a supporting simulation here. I can press play. I can see all these water particles are moving around. Okay. And what this is showing me is really, I'm tracing one particular particle. And I am taking a look, and it traces that path for only a certain amount of time. Right? So over the past 5 seconds or so, this is where that particle has been. I can change the temperature and I can make it much lower. I can see how quickly that path has gotten so much smaller. Same thing would happen if I turn this up all the way. Okay, everything is moving faster, and this particle is covering much more area in the same amount of time. I'm not changing, I'm not speeding up. It's not like pressing fast forward on Netflix. This is all in the same time frame. It's just us changing, figuratively, of course, the temperature of this water. So this is the supporting simulation for 1.3. Okay, coming back, there's a check for understanding. Again, I'm trying to boil this down. We're going to wrap up pretty much our new content with Unit 2 Investigation 1. Like I said in the beginning, we are going to go live tomorrow, just mainly to go over a lot of the things that we are seeing. What we need to know pretty much for the end of the semester. We're getting here to the final stretch. I apologize. I'm sort of trying to look at my notes and make sure I'm not missing anything. 1.2, 1.3 for today and tomorrow. I'll see you guys in our live session tomorrow. If you have any questions, shoot them to me on Schoology. All right, I'll see you later.